So the person that wrote it is somebody who writes for the AP. And so she, cognizant of what's happening this year, was trying to catch as much BC material as possible in one question, because you got the grand total of 2 questions, 60%, 40%, and you got a grade for an entire class, which is crazy. So that's why I wanted to make sure I gave this to you. And if I can dig up more stuff like that, I'm still in touch with her. So we'll see what else we can figure out. But just for now, I'm going to throw you into groups and have you guys discuss, talk for about 10 minutes, and then we'll come back together and take a look at this. So hold on. Okay, you guys, so we're back together. I don't know why this is on a weirdo screen, but it is. Okay. So I saw a lot of really good work. I was impressed. Let me see. Here we go. Okay, so just so that you can check to see if you're right. So here's the story with this. Each of these parts has totally different skills involved. The first is like an A-B skill. So and typically BC questions will start like that. Like you'll at least get part A right, or you'll get something right because it's something that is old enough that you're not trying to come up with BC material. So this is just finding the derivative using the product rule, which clearly people got because you all got 52 for that. So that's awesome. The second one is where, let's see, where you have use of. Again, it's an A-B idea. And the way that you know it's a use of is that you've got some derivative, and inside of here is a function. And we know h of x. They gave us h of x. So that was, I can't remember what it was, but that we knew. So if you knew that this was true, you could find f of -1 because you could integrate this making a use of, which, again, people did fabulously on. So your u was h of x, take its derivative, and then f prime of u du is 1/2, and then you wind up with something 7 minus 44/3 and a negative value when you're done, which isn't a huge surprise. So think about it. From 2 to 4, if this were an accumulation function and you were starting at 2, you would be accumulating positive values for this, and then from that you're going to be subtracting. So the graph is fairly accurate. So it's not a big surprise that you get negative 23/3. Not that you want to always look at the graph. Here you would have to, because they didn't even give you a function. But sometimes, you don't want to rely just on the graph. You'd want to do some analysis. But in this case, that's exactly what you would do. The next one, this was integration by parts. And the way that you know it is that you've got 2 different functions that are multiplied. And you can't undo a product rule unless you have some sneaky smart method, which we do. We've got integration by parts. Because this is a derivative, this is the one that you're going to want to be able to integrate because the values for that are over here. So when you're making these up, you would say, okay, well, I know this is h, so that's easy to take the derivative of. So if I let that be u and let dv be f double prime, then its derivative is f prime. And that. And then hiding under here is the rest of it. So this is saying, so here it is. This is ultraviolet voodoo. So u times v minus the integral of v du. And then you can continue on with this and integrate it. So you can integrate each of them on their own. This is already integrated. Sorry, this is already integrated. So that's what this is. And then f prime of 1, h of 1 is the rest of this. And I think everybody got the -8 for this, which is awesome. Okay, the next part, you would look at this and say, I don't know what the heck to do. However, the bottom is 2 things that are multiplied. I've got 2 functions that are multiplied. That reminds me an awful lot of polynomials, which were factored. So like x plus 1, x minus 5, or something like that. So hopefully that would engender in you the idea of partial fractions, which is on the AP. So partial fractions. You let one of them be over the first factor, so 6x over this is going to be a over f prime, b over h. Solve it through for those variables, put it back together, and you're going to have natural logs in your answer, because when you do the u sub for these, you're going to be left with, and just be really careful, because the u subs, you can't just write ln of this. The u sub for this is going to demand that you have a negative 1/2 on the outside, so that's why you've got like 4 and 5 halves and another 5 halves. So, and when you get to here, so I saw people, wait, hang on, it's underneath here. And I was curious about how they got the answer, not because you couldn't get the answer this way, but typically if you get to here, where is it, to right here, you just want to stop. You can distribute the 4, and I'm not saying it's wrong that you don't, but if you distribute the 4 and you get 6 over 4, which is 3 over 2, then you would have the 4 on the outside, you would have this, 5 halves, ln 3, but you don't really have to simplify this. So you can be sneaky smart and do this stuff. I wouldn't chance it. I would just stop here and say, I don't know, ln 4, you guys can figure out ln 4 if you really must, and ln 1, rather than squish it back together. But if you squish it, and you squish it correctly, you would get the point for that. And then the last one pulls it all together with the ultimate BC topic. So this is Taylor series, which is what you guys have been working on. And here you're going to need successive derivatives with the factorials in the bottom, and then increasing powers of x minus 1 since it's centered around 1. So this, again, remember, on the exam, they're interested in conceptual understanding, not whether you can find derivatives of crazy things. So it's likely, especially because calculators are going to be irrelevant on this. You can have one, but it's probably not really going to help you. So you would have to understand the concepts. So when you go back, if you go back and look at the recording for this, I have to edit it and upload it to YouTube and all that kind of stuff. But you can actually stop on this page and take a look at, if you didn't get an answer, if you're not sure how something worked out, you can look at this page. Okay? So what I'm going to do, this is just me working stuff out. I looked at, let me just clear this for a second. I looked at the form that you filled out about what people really, really, really need to work on, and except for 2 people, every single person talked about integration, applications of integration, volumes of revolution, stuff like that. So I thought the most pressing thing to do, in the order of pressing things to do, would be to work a little bit on that. So that's what this is. So these are just some reminders. When you have average value of a function versus average rate of change. Average rate of change is just slope. So you can go and try to confuse people and say, oh, what's the average rate of change? Well, it's just the slope, y2 minus y1. That's what this is. So average rate of change is the quality of the function. It's what is the slope on a given interval. Average value is not a quality of the function, like something like a derivative. It's an actual y value on the function itself. And you're saying, on this particular interval, what is the average y value? So, for example, if you have a cup of coffee that is heating up, if I say, if I ask you this question, and I say, what is this? Well, you would say, that's the average rate of change. That means, overall, it's changing at the rate of 3 degrees per minute. That's a degrees per minute problem. If I say, hey, what's the average value of the coffee, you're going to do this and say, whatever the answer is, the average value of the coffee, not the average value, the average temperature of the coffee on a temperature graph is 100 degrees, whatever it is. So 2 different things. This average value is an integral problem. Average rate of change is a derivative problem. And they're going to ask you to put things in context. So if you have rain falling on a house or on anything else from 0 to 3, and you've got centimeters per hour and hours, this is a rate. So this one is the average rate at which the rain is falling is whatever this is. So because it's centimeters per hour, that's your original graph. That's not because you're figuring out a rate. It's because the actual original graph is a rate. So, and we'll get more into that. I'm rattling because I'm so excited to be back. Units, 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 units. Don't forget to put units. They give you an entire point. If they ask for units, please do that. Here's another one that is reliant on average rate of change versus average value. So in this case, if you read, this is talking about, it's just what I was talking about, temperature of water in a jug in a refrigerator, and you're measuring in degrees, and the T is in minutes. So if I were to draw this, I'll just do this really, really fast, because I don't want to spend a ton of time on it. But whatever the thing is, let's say it's, let's see, what are we doing? We've got a water that's in a jug, and it's going to get close to some value. This really wouldn't go up, but okay, that's really ugly. But anyway, if they ask you this, you're going to say, well, that means that the temperature at 5 is changing at the rate of negative 2.1, or you could say decreasing at the rate of 2.1 degrees per minute.
On the recording, when we were actually in class, what is omitted on here, there should be a prime. There's a mistake on this particular question. This should say W prime of 5, and then the recording will make sense. The way it's written here is not as a rate, but that is a mistake on this problem. So just to be aware, this should say W prime of 5.
Between 0 and 5, so whatever this thing looks like, on this interval, let's assume it hits the x-axis. What is the average temperature? Well, you're saying the average temperature is 44 degrees. So let's say it's here, 44 degrees is your average temperature. That's the 1 over 5 times the interval. That is the average value. So two different things. People get them confused all the time. Another thing I've been jumping around about all year, and most everybody does this. I'm so delighted. Just make sure you go to 3 places after the decimal. Not 3 significant digits. So don't think of sig figs. We're talking about 3 places after the decimal. If you're not sure, go to 4. What the heck? Live large. So if something is not exact, I don't anticipate you not being, not using, okay. I don't anticipate you needing decimals to do what you're doing on the exam, but should you use decimals, that's okay as long as your accuracy is correct and as long as you store your non-exact values. Label it A or B or banana or whatever you want to call it, but let them know, hey, banana means blah, blah, whatever it is. I wouldn't go with banana, but it would be fun to do my class. Okay. I've jumped around about this too. Don't use pronouns. Don't say it. Don't say the graph. Don't say the function. Don't say it changes sign there. Well, where? What are you talking about? On the moon or at time equals 3. Please don't erase things for 2 reasons. Number 1, it might be right. Number 2, if you're sure it's wrong and you cross it out, they will not look at it as though it's invisible. If you're on a free response question, write something. Don't leave it blank. Please don't leave it blank. So, you know, even they will look for things to give you points on. So you can't lose points. You can only earn them. If you really don't know what you're doing for part A, you just write a bunch of BS, BS, BS. That is my answer, I. Or if you're living, you know, if you want to be really sneaky, you could say E is my answer, even though it's totally wrong. But then take that answer and continue using it, because your first part is totally wrong, but you know what to do with it. So, and we've talked about that. Content to focus on, average value, position, velocity, acceleration. These are all integral ideas that you will see on the exam in some form or another. So if and when you go back to look at this, you can take a look at those. This is also from an updated part of the AP College Board site. So they're trying to really help you focus, because it's just, we just have so much to do in 45 minutes, which is nuts. Cross sections, discs and washers, arc length. We'll touch on those just a little bit today. And before I I do that. My guess is you don't remember things like left-hand thumb, right-hand thumb, trapezoidal thumb. So let me give you a minute or so and just read through this. The context for this, because I stole this from a question where the other part wasn't really, it wasn't tremendously, it wasn't this. So I said I don't really care about that. But this EFT means entries in a contest. So number of entries in a contest. So just take a minute, read through that so this, I'm not just rattling on to you. A. I guess I could have said A. But trapezoidal thumb is reliant on the geometry formula, 1/2 the height times base 1 plus base 2. And there's a formula that we teach and then we say don't do it. Here's a nice formula. Just forget I said that. Because it relies on the idea that your intervals are the same. So this would have to be going from 0 to 2 to 4 to 6 to 8. Here I'm going 0 to 5, 7, 8. So not something that you can apply a formula to, and you don't need to. So if I'm doing this, oftentimes I will draw a picture first. You do not need to draw a picture. But you can graph those points and then come up with the trapezoidal thumb and then explain it. So I want to give you guys some time to work this out with an explanation. And then when you're done, just raise your hand. Okay, so let's take a look at this. So here's what I did. I said, I can use this formula. I love pictures, so I drew the picture for this. And that way I can see the heights. Otherwise, I don't know why this gets to me. So you're doing 1/8 of this integral using the trapezoidal rule, 1/2 base 1 plus base 2 times the height. So base 1 plus base 2 times the height, base 1 base 2 times the height, blah, blah, blah. Multiply that by 1/8, and that is the average number of entries in hundreds during the first 8 hours of the contest. Now, you don't have to work this out. If you powered through and you worked it out, I don't even know what you get. I'm sure you guys know what you got. But you could have stopped right here and said, whatever that stuff is, means this is the average number of entries. Not the average rate of change. It's an average value of this function, whatever it is, on this curve. Another thing I want to alert you to is if they had asked you, let's say it was a different question, and wanted the average rate of change, the average rate of change, or they wanted a rate of change at a particular point, do not interpolate. Don't say, well, it went from 4 to 13, half of that, subtracted, and, just make up some value in here, because you don't know what's happening in between. So you could be going from 4 and then land at 13. So you can't just make up values off of the table. And that's always a big hint. When they say use a trapezoidal sub of 4 subintervals, that means they really do want you to use each one of these. This is just a triangle, but everybody else is a trapezoid. Okay? So give me a little emotion. You get what's going on. You fell asleep, but you just woke up. Something fun. Okay, that's good. Looks like you guys are with me. Somebody raised their hand, but it could be just that you have Tourette's. I don't know. Roger, what's up? Or did you retract your hand raising? I'm so happy you guys are here. I miss seeing you. I miss seeing your cute faces. Okay. This type of a question, now I don't know how much you remember about revolving things, but the big deal with this is unless it's a volume of rotation, you don't necessarily have a pi. So like for this one, when you're setting up triangles on a base, you're not going to have a pi for this, because that's just whatever the area is integrated between the regions. So this is not an actual AP question. It was from a review that had you doing something for R and then for S and then for R. So really this was like 14 questions in one. If I were to find the area, so I'm not going to go through every tiny little thing for this because I just want to talk through it. The next example is the one I really, really want to hit up. But when you're finding the area, let's say you're finding the area for region S. For region S, you're going to be doing top minus bottom. So let me just say that the top curve, top, is tangent, bottom is 2 minus x cubed. You would need to find this point of intersection. And that happens to be, only because I did it before, about 0.909, which of course you would store, or 902 or something like that. I don't know. Let me look at my calculator. I did do this. It's probably not 904. No, 0.902. But what you want to do is find that, and then you are going to do something fun. Let's see, 0.902-ish. Just make sure that that's stored. And then for that area, you're going to do, I'm going to say T and B, because I don't want to write, of course I could have written f of x and g of x, but you're going to do top minus bottom dx. What if I wanted region R?
Okay, again, one retraction with this is, as I was reviewing the video, my top curve, it's kind of hard because it looks like this is on top and that is on bottom. But really it's the reverse, because if you follow this curve up, your top curve is 2 minus x cubed. So this should really be the top. And then tangent x, because we're dealing with region S, tangent S is the bottom curve. So really this guy should be top minus bottom. I would rewrite this, but I can't on this screen because this is just a recording. But I just wanted to make that clear.
I don't need you to raise your hand and do stuff. You can just, if you want to text it in, that's fine. What would you do if I want the area of this region, not S? So this is for region S. The area would be that. So what would you do for R? Excellent. So Raghu is saying it, and I'm sure people are typing in stuff, which is fantastic. So we got one person. You guys can go ahead and send. I would love to hear what you have to say. Awesome. Ani, did you have a suggestion too? I know you're writing too. Or maybe not. Maybe people said we should even say. So you can do it two different ways for this, because you can find where this splits, and you can integrate from 0 to 0.902 and then 0.902 to here. Your curves would switch. Potentially an easier way to do this would be to solve this for x and solve that for x. So you would have inverse tangent y, and you would have the cube root of what? I don't know, 2 minus y, I think. And then you could do right minus left. Then you would have to be going from 0 to 1.267. So you can integrate up the y if you do it as a dy right minus left, or you can still do top minus bottom. You would just have to make two separate integrals. Okay. So that's that. When I have volumes, you have to be careful that you are making sure there's not a hole in the middle, or it's smashed up against whatever the axis. If it's right against the axis, that's fantastic. You have only one radius. So remember that volume is just pi r squared. That's all we're doing. It's geometry. When I have region S rotated around the x-axis, do I have a hole for that or not? I've got this S, and I'm rotating it around. Do I have 1 or 2 radii? Okay, so Braden's saying 2. because his name is Braden, he's probably right. I don't know if you guys are awake or what. Sure, you're going to have 2 radii. Let me get rid of these little things, because that's distracting to me. So I'm talking about this. If I can make this work. We're talking about S. S is this. I'm rotating it around the x-axis, which means I've got a radius from the x-axis to the top curve, and then I've got another radius from the x-axis to the little curve. So there's a big hole in the middle of there. So when you're doing this, you're going to have to do, hold on, pi times the integral from 0 to 0.902. Big, so let's see, it's going to be 2 minus x cubed squared minus tan x. Make sure I did that right. Nope, not backwards. Big minus little. Oh no, it is right. It's so weird because this is drawn up to me upside down, but whatever. Okay. Tan x squared. So you just have to make sure that you understand whether there's going to be a hole or not. If there is a hole, you have to square it independently. Don't just write this whole thing out and square it. That's the most common mistake. The same thing applies to these. I'm not going to take the time to do these. The only one I might set up is this, maybe with region R. So equilateral triangles, region R only. So we're talking about this. And they are perpendicular to the x-axis. Let me think. Perpendicular to the x-axis, equilateral triangles, region R, semicircles, region S. So what I'll do is just set up the integral. You know the area is 1/2 base times height. And so that's what you're going to use, but you got to figure out what the base is going to be. So cross section is perpendicular to the x-axis using equilateral triangles. When you're doing this, let's see, you got this, and perpendicular to the x-axis. Okay. So we're looking at this. Here you do need to know where it breaks. So you're going to integrate up to this green line, and then from there you're going to make a new integral. So you'll have, oh my goodness, area of an equilateral triangle. So you get these equilateral triangles popping out at you. I don't really know a nice way to draw this. Let's see if I can do this. So here's your base. Here's a triangle, supposedly equilateral. It looks like a right triangle, but whatever. And remember, this is where you have to come up with 1/2 base times height. You need to know the height. So if you look at one of those equilateral triangles straight on, for that first part, the base length, so I'm talking about this length, if you can see that, that length is determined by the tangent curve. This whole thing is tan x. So this is 1/2 tangent x. And that means this is 1/2 tangent x square root of 3. That's my height. Because in a equilateral triangle, it's a 2a, a times the square root of 3. So just for that part, you would be saying, okay, I'm going from 0 to 0.902 of 1/2 tan x. So that's 1/2 base times height, which is again 1/2 tan x square root of 3. So that's just for the first part. And then to that, you have to add the rest of it. So get rid of this and that and that. So you take plus, now go from 0.902 whatever this is. I don't even know. 0.902 to whatever. I'm just going to say K or something because I didn't work this out. I'm doing it completely on the fly. From there to K of, same thing, but now my curve is going to change. So when I do my equilateral triangle, the base is now 2 minus x cubed. So half of that, which is this part, is 1/2 2 minus x cubed. We only care about that because the height is related to that. So if I'm dealing with the height, this height is square root of 3 over 2 minus x cubed. Whoops. Yeah, that's right. Except that this is here. So you'll have 1/2. And I just realized that this is not half tangent x. This is just tangent x. This is 1/2 is not here. So this whole base is still tangent x. It's still from here to, from here to here. So the 1/2 was just relevant to the height. And then similarly with this one. So it'll be 1/2 base. Well, my base is now 2 minus x cubed. Times square root of 3 over 2 minus x cubed. So just be careful as you're doing these, particularly the equilateral triangles, that you're thinking about how am I going to get the height for that. Semicircles, the only hitch with those are that a lot of people will say, oh, the base of my semicircle, if they were dealing with S, the base of my semicircle is this. And just be careful because that's actually a diameter. So when you're doing semicircles, you have to think about you need a radius in order to do a semicircle. So those are just some heads up for this. The one I really, really want to pay attention to is the crazy one, which is, whoops, all of these are so much fun. I had so many things this morning, 5 a.m., I'm like scouting out things to show you. There's just so many of them that I was excited about. But this is a really good one because, let me stop and let you read it. I'm too excited and I'm just going to rattle on. So let me stop and just let you read through this. And I want you to think about how would you set this first one up. So, and in fact, I want you to set it up, type it in, and then wait. So read through this, do A, just type in what you think your final answer is, and then stop. And hit send. See what you guys got. Okay, this is looking pretty good. Seeing lots of pie. I would like to eat a pie. All right. So excellent. You guys are right on the money. You would say pi times the integral from 0 to k of 3x over x cubed plus 1, the quantity squared dx. Now, here's the conundrum. They're not just asking you to set it up. They want you to find an expression in terms of k. So what would you do? How would you go about integrating this? Any ideas? And again, you can just text it out, shout it out, grab your mic, I don't care. What could you do to integrate this? Any ideas? And don't be afraid. It's fine to be wrong. It's even better if you're wrong, honestly. Because then you understand, oh, that makes sense. Any ideas? Just think about that. It's kind of strange because my first thing would be a u sub, but then wait a minute, I can't do that. I've got x cubed. I'm not going to get x squared. What the heck? Any ideas? You guys are so cute. You have such creative ways to do it. I wouldn't factor out the bottom, and I don't think x cubed plus 1, I don't know, Ani, if you mean like factoring it, like x plus 1 with the sum of cubes. But here's what I would do, because I was stuck like a truck, and then I went, wait, I can be sneaky smart. Check this out. What if I simplify part of this, and I call the top 9x squared, but I keep the bottom, x cubed plus 1 quantity squared. Ooh, look at the fun we're about to have. When I did this, I said, oh, it's possible. What can I do? Scream it out. It's crying to be solved. U sub! So you force it into a situation where, I will make you a U sub. So I take out the 9 with the pi, and I say, okay, so here's what I'm really going to deal with. How fun is this? My U sub, my u is going to be x cubed plus 1, the derivative of which is going to give me 1/3 du equals x squared dx. Exactly what I wanted. So this 3 will go play with the 9. So 9 over 3 is going to give me 3 pi on the outside. I now have u to the negative 2 du, but I need to be careful because I'm really and truly integrating this. So on the bottom, instead of 0, which it would have been 0, I'm going to call this 0 squared plus 1, or 1. On the top, instead of k, I'm going to call it k cubed plus 1. But I can still do it. So I'll have negative 3 pi u to the negative 1 integrated from 1 to k cubed plus 1. And just in case you're wondering, this negative came from this integral. So this was u to the negative 1 over negative 1. So there would have been a negative right here. I just pulled it out and stuck it with the 3 because I don't want to mess with that. I'm going to leave this constant and then worry about it later. So that's what happens with that. When you integrate this, you're going to get negative 3 pi. And that's going to be multiplied by 1 over k cubed plus 1 minus 1. We are done. Look at that. What was thought to be impossible has now been proven possible. But typical AP thing, you know, I mean, I want, what, K? Come on. What do you mean K? Well, you just get a K in your answer, that's fine. This last part is the money. This is the part that you have to be in, like this, I could give this to an AD person. Not impossible, they just would not like you. But I could not do that with this one. I want you to think about how would you set this up? Take a second and read that. So just think about what they're asking you to do. This is a crazy one. I'm going to draw as you're thinking. It's asking you to rotate this infinite region. Integrate till you're dead, give it to your grandchildren, let them integrate. What do you need to do for this? How do I integrate forever? You are making my day. just love you guys. I'm so happy. It brings me to tears. It almost does, actually. Okay. You're right. So I have an infinite integral, improper integral, my favorite type, improper integral. Ugh. I'm going to integrate pi times the integral from k to infinity. So I'll set it up like this first, but then I'll have to put limits in it because I can't just leave the infinity up there. I have to look back at what this was. I don't remember. 3x over thing. Okay. 3x. Actually, I'm going to make it into the other thing that I was talking about. 9x squared. 9x squared over x cubed plus 1 squared dx. And I can't do that. I got to say, okay, well, what I'm going to do is take the limit of that. So I'll take pi times the limit as b approaches infinity of the integral from k to b, 9x squared over x cubed plus 1, the quantity squared, dx. I need to know when is that equal to this. So that was the answer we got from the last time. 1 over k cubed plus 1 minus 1. I hope that's what we got. Yes, we did. Okay. And then the process is, I just jumped out of the classroom. Process is the same. So I'll have negative 3 pi out here. This will be u to the negative 1. This is k cubed plus 1, and this is b cubed plus 1. So I'm skipping right from the results from the last time. I'm not going through that again. I'm just saying, hey, this is when I'm in U land, that's what this looks like. If I work it out, negative 3 pi, 1 over b cubed plus 1 minus 1 over k cubed plus 1 equals, bring this stuff down, 3 pi, and then 1 over k cubed plus 1 minus 1. Look at that. Something's funny, and I don't know what it is. I have to think for a second. What is funny? K cubed minus 1. I don't know. I feel like something is weird, and I don't know what it is. But that's the setup for it, and I did work it out, so I don't want to try to locate errors. If there, I don't think there were any. It's feeling weird to me. So all of this gobbledygook on here was me working it out at 5 a.m. So what happens is this is what we were just doing. I've got this thing squared, integrated, and we were right here. We had 1 over k cubed plus 1. Where did it go? It started, wait, here it is. So negative 3 pi times negative 1 over k cubed plus 1. And that winds up being something completely unclear. This wipes that out. And what I did is I distributed this negative. So what happened? This became 1 minus 1 over k cubed plus 1. Yes. Yes. And this is not negative. I don't know, there's something funny about this, and I still don't, I'm not seeing where it is, but it's fine, because I know that the result is correct. But then you move this, you now have 2 of them, cross multiply, you get k cubed equals 1, therefore k is equal to 1. All of that we did, you realize, just to say the answer is 1. I am resting my case. When in doubt, just write down 1, E, or 0, and you're probably right. So after all of that, if I go from 0 to 1, the volume of this R region, if I rotate it, will be exactly equal to the volume of this S region if I integrate forever. Crazy. So that was the one I really wanted to show you because it dealt with so many different aspects. So let me just get a little bit of emotion. I'm just going on and on. I'm so excited about math. I can't stand it. Let me just find out if you guys are alive, awake with me. Look at all these happy people. And please let me know if you have a question. That's not like I'm expecting everybody to be completely questionless, question-free. I'm seeing a lot of good stuff. Okay, so I'm going to stop the recording.